Hey, what's up, guys? So let's solve in these 336 palindrome pairs. Okay, so given a unique words, return all the pairs distinct ij, so that the word I and word j is palindrome. Okay, so for example, 01 means that ABCD plus DCBA, right, is a palindrome. Yeah, right. And 10 is DCBA plus ABCD is a palindrome. And SLLS is S plus LLS. Or 24, which LLS plus SSSLL is a palindrome. Okay. So the simple idea, the first come up with the idea is the brute force. Okay. And oh, by the way, hope you guys subscribe to my channel. So brute force means that right. So given an array L, let's say the length is n, right? Then you can take the n squared minus n pairs. Okay, and you just check whether it's a palindrome or not, right? So suppose the length of each, the maximum length is L, right? This complexity is n squared because they're n squared pair, and then times a palindrome that you need to check. Okay, but let me just, right? So this is a brute force. You check this is palindrome, and then you check that go through array, and if they are different, and then you check there whether it's palindrome or not. Okay, but if you use this, it's a time limit out, right? So you can solve maybe some of them, and maybe I guess maybe 100, maybe 50% of them, right? So this is a brute force solution, doesn't work. Okay, but let's see some better solution. Okay, so the better solution, let me just explain it, right? So the better solution is that let's say you first create a dictionary. So let's say you create a dictionary called index, right? So the idea is that you first create a dictionary, and these dictionary just need to be for us to very quickly check, right? So index, this is a dictionary such that each key is the reverse of the words, right? So basically, for each word, you just reverse. Okay, this is just for our purpose, and records index, right? So for each words, you just do a reverse, and the records index. Okay. So for example, for this first one, that your index look like DCBA 0 and ABCD 1 and SSL 2 and S3 and LLSS 4. Okay. So once you have these reverse indexes, then the problem can be will be trivial, right? So let's say now you go through each words. Okay, so once you create it, so let's just take the O n time, right? And then you create, let's say for each word, right? Let's say you get word, but you separate it into left and right. Okay, so if you add, so you have two choices, right? The first choice you add something here, which make it become palindrome, or you make it here, right? So suppose you can find something here. Okay, so that means what? If you can find something here, that means that there is a word which is the reverse of the left. Okay, so this means that the left is in indexes, right? Basically, you can find something, and also right is a palindrome. Correct, right? If this guy is a palindrome, and you can find another another word which is exactly the left reverse, basically it's in our indexes, then you get an answer, right? And the only requirement is that you are not allowed these three to be the same, right? Otherwise it's trivial, right? So you need to check that where the index is left. Sorry, where the index is left, it's not the same as the right, right? So you need to check the indices is not the same. Okay, this is the first situation. And the second situation is that you do the same thing, right? And the left and the right. And in this case, you try to add here, right? So that means this guy is a palindrome. And then there's a right. Your right is in the indices. Right, your right is in the indices, right? So it means there is some guy which you reverse, and then it becomes this, and this is a palindrome. Okay. So that's it, right? So this will be super fast, not so fast, but still can solve, right? So basically, you create a dictionary and then you create a solution to be a set. Okay, and because the answer must be unique, right? So you create a set, and then you go through original words, and then you go through each word, you separate it into left and right. As I said, if you write in indices, this is the first part. That means there is a here, right? So if you write these indices, and the palindrome is the left, and the index right is not the same as it, then you can add a right and I, right? Because that means that your right plus this guy will be the palindrome, okay? Because this guy now is the same, right? So and this guy per is a palindrome, right? So total is a palindrome. Okay, so this is the one step. The second step is that if left in the indices, right? And the palindromes, right? That means you can add right, right? So you need to check that where left indices is not the same as I. Yeah. Okay, so yeah. So I need to check that where this guy is not the same as this. Right, so that's it. And then you just add a solution and then return a solution. That's it. Okay. I might say something wrong about this in this, but it's very easy that you guys can check. Right. Basically, it's so once you've done this, then you can solve this problem. Right. So one brute force cannot solve it, right? But for this problem, you can use this, and not so terrible. Okay. So see you guys next videos.